Now we shall be talking about the dehydrohalogenation reaction, which is an elimination reaction. Talking about the dehydrohalogenation reaction, this reaction is a simple reaction in which we have the halogen and hydrogen and we eliminate HX from it to give an alkene. Talking about this particular reaction, that how this reaction takes place, this is actually a base assisted elimination reaction. I'm not talking about the base catalyzed reaction because a catalyst is a typical compound which takes part in the reaction, but its concentration does not change throughout the reaction. It actually is regenerated in the reaction itself. This reaction, the base is actually consumed. So here we are using the word base assisted elimination. Many a times the student have a confusion about the difference between a base and a nucleophile. Now, let's understand one particular simple fact that base as well as nucleophile are both electron-rich species. These both are electron-rich species. Then how do we distinguish between a base and a nucleophile? Base is a species which attacks on hydrogen and eliminates H+. Whereas a nucleophile is a species which attacks on any electron deficient position other than hydrogen and attaches to it. Attaches to electron deficient position other than hydrogen. So the same species has the capacity to act as a nucleophile or a base depending on the condition. In fact, the way a species behaves will decide whether it is a nucleophile or a base. Now let us understand what are the conditions in which a species would behave as a base and what are the conditions in which the species would behave as a nucleophile. In fact, we have the opposing conditions when the species behaves as a base or as a nucleophile. If we know the condition in which a species would behave as a base, just have the opposite condition, those will be the condition when it behaves as a nucleophile. When the species behaves as a base, it will be causing elimination reaction, but when it behaves as a nucleophile, it will be having the substitution reaction. So let's consider the factors which favor the elimination reaction. The factors favoring elimination reaction, that is, the factors which favor the behavior as base. The very first factor which favor the attack as a base is the presence of a very strong base. If the attacking species is an extremely strong base, then in that case it's going to behave as a base rather than a nucleophile. A peculiar example of this sort is that if we have aqueous KOH, then the attacking species is OH minus. Here it will behave as a nucleophile and it will do the substitution reaction. On the other hand, if we have alcoholic potassium hydroxide, in this case, the attacking species actually turns out to be C2H5O minus, which is a much stronger base, and this will behave as a base and the reaction would be elimination. So, aqueous KOH substitution, alcoholic KOH elimination. Second, high temperature. The oxygen carbon bond is stronger than carbon halogen bond. In fact, the carbon halogen bond is much weaker than most of the bonds which could be formed by carbon. And therefore, if we have any species attacking carbon, then in that case, the substitution reaction would be the favorable reaction as it is going to be exothermic reaction. So if we have the temperature low, the equilibrium simply tells us that a low temperature favors the exothermic reaction, which in turn turns out to be substitution. But when we have high temperature, the elimination reaction is actually endothermic. Here, the bonds are being broken and the bonds which are being formed are actually weaker than that. Further, the elimination reaction leads to the formation of more species than the species which are initially. Elimination at least talks about the two species which are being formed. So elimination is an entropy favored, the disorder favored reaction. Further, elimination also generally produces the products which have low melting and boiling point. So that means it produces more of gases. Again, it becomes entropy favored or temperature favored reaction. So as the temperature increases, the elimination reactions have much higher possibility to take place. And so at higher temperature, an electron-rich species has a more possibility to behave as a base rather than a nucleophile. Now, many a times we understand that the high temperature would favor the elimination reaction. So many a times students ask, how do we know it is a high temperature? The simple answers would be that we have the arrow, on it it's written heat, or it is written high temperature, or there is a word called reflux, which is being used many a times to represent high temperature. What exactly is reflux? Here we have a distillation flask, and on this distillation flask, we have the normal distillation condenser. But here, instead of making it horizontal, we have made the distillation condenser vertical. Here is going to be one opening, the upper opening, and here we have the lower opening. The inlet of water is always the lower opening, whether it be horizontal or whether it be vertical. Now, what happens is here the reaction is taking place, we heat it. Now, when the water is circulating, the tube is cooled, and when the vapors rise, these vapors are going to condense and fall back into the flask, the distillation flask. Now, what is the benefit of it? There are basically two benefits. First benefit is that solvent is not lost. Whatever amount of reactant we take, that amount of reactant is maintained throughout the reaction so that the reaction can be carried out for very long duration without loss of solvent. So this is the first reason. Further, in this reaction, the substance which is going to escape out is going to be the one which is actually a gas at room temperature. So only the gases are going to escape out. Further, we have not closed the opening. It is open. At the most, we generally put a cotton plug so that it is remaining porous and something from outside does not fall in it. So this is a particular method of maintaining the pressure as the normal atmospheric pressure and continuing the reaction for as long as is required. So this is what we have as reflux. Reflux greatly favors elimination reaction. So that is the second case. The high temperature favors elimination reaction. Third, high steric hindrance, that is high crowding on the carbon containing halogen. Now, if the carbon containing halogen is going to be crowded, then in that case, it will become difficult for the nucleophile to reach carbon, and then in that case, the base is going to attack on the hydrogen. For example, if we have CH3, CH2, Cl reacting with NaC2NaOC2H5, then the product is going to be CH3, CH2, OCH2, CH3. But in the same case, if we have CH3, CH, CH3, Cl, now here the chlorine is attached to a secondary carbon. secondary carbon is more sterically hindered as compared to the primary carbon. And here, if it is treated with NaOC2H5, then the major product is going to turn out to be the alkene CH2 double bond CH2 along with C2H5OH. And here it's going to be NaCl. And obviously here also NaCl is formed. As you can very well see, in elimination reaction, the right side has three products and left hand side has two reactant. While in substitution, on the left hand side also we have two reactant and product also has two products. So this is high steric hindrance on the carbon containing the halogen. Further, there is a fourth factor which favors elimination reaction. The fourth factor is bulky strong base. The bulky strong base would have a difficulty in reaching the carbon to do substitution reaction. So if we have a bulky strong base, then in that case, elimination reactions are becoming more favored. Something like if we have CH3, CH2, O minus, Na plus. This particular base prefers to do substitution reaction. On the other hand, we have CH3, C, CH3, CH3, O minus, K plus, that is potassium tertiary butoxide. This is an extremely bulky base which prefers to do elimination reaction. So these are the factors which favor substitution. These are the factors which favor elimination reaction. Just do the opposite of these. You are going to get the substitution reaction. Now, let us understand the mechanism of the elimination reaction. Let us say we have this particular species and we have halogen here. Or now we need to understand that nucleophile or a base is an electron-rich species. The halogen also is an electron-rich species. The halogen also is going to have a negative charge. Since halogen is a negative species, is an electron-rich species, if another electron-rich species has to approach the group, the compound, the molecule, then it will always do so from the position which is farthest from the halogen. And that would be the diagonally opposite position. So the base would approach from the position which is diagonally opposite to the halogen. Considering this particular position, what we can say is that if somehow this position does not contain hydrogen, then elimination reaction will not take place. So here the base is going to attack the hydrogen from the point farthest from the halogen. When the base attacks the hydrogen, it is going to donate the electron cloud to the hydrogen. Hydrogen has a valency of 1. So if the electron cloud is donated to hydrogen, it will have to break the hydrogen carbon bond. The bond would shift here and the halogen would be released out. So we are going to get the product as H base along with C double bond C along with X minus. So this is going to be the elimination reaction. Now this entire reaction takes place in a single step with a transition state. No intermediate is formed. The reaction which takes place in a single step is obviously termed as an elementary or a single step reaction. Now this is an elimination reaction. And the single step of this particular reaction involves two independent species. Now please remember, any independent species, that is a species which can exist by itself under the given set of conditions, is termed as a molecule. So here in this particular reaction we have two molecules. One molecule is of alkyl halide while the other molecule is of the base. So this particular reaction is elimination by molecular. Now, I believe you have understood why we talk about the word as elimination, and you have understood why we talk about the term as bimolecular. Elimination because in this reaction HX is being removed, and bimolecular because this particular step involves the reaction of two independent species. The two independent species being the alkyl halide and the base. So that is why this particular reaction is elimination, bimolecular. It is a single step reaction and it gives us the product. So that's what we have as the mechanism of elimination reaction, the elimination bimolecular. Now, this is the mechanism of the elimination reaction. Now let's talk about the reaction, the other substitution.